Hello and welcome to SAGacia25, a symposium of art looking to science. I'm Greta Peruzzi, one of the organizers of this project, and today I will bring you through the SAGacia Art and Science exhibition. SAGacia25 was born from a desire to reconnect two fields that often see as worlds apart, art and science. Historically, these two disciplines were closely linked. Just think of figures like Leonardo da Vinci or Galileo Galilei. But over the last 2 centuries, they've grown increasingly distant, partly due to the rise of scientific specialization. Through this exhibition and broader SAGacia initiative, we've tried to bring them back into conversation, uniting their power in service of a common cause, raising awareness about the environmental changes we face today. This year's themes focuses on environmental impact of extracting natural resources, especially those known as critical raw materials, essential to our economy and to the health of our planet. We've taken a transdisciplinary approach, artworks that engage with scientific issues and scientific phenomena brought to life through artistic expression. For more information, feel free to scan the QR code at the entrance and browse the digital catalog. We begin our journey with Pesci, Fish, by Italian artist Marco Mazzei. At the museum entrance, you see a large fish made from hand-hammered aluminium. But the real meaning of the work isn't in its shape or technique. It lies in the material. Aluminium is extracted from bauxite, a mineral typically mined in open pits across the world, often in regions where environmental regulations are weak or non-existent. The resulting damage, especially to marine ecosystems, can be devastating. This brings us to the artist's provocative question: what is a fish doing in a chemistry museum? Mazzei's answer: it escaped. Its home is too polluted. It is a powerful symbolic message, one the artist has taken across Italy. Indeed, his aluminium fish appear not just here at Scienza University, but in cities nationwide, used in public awareness campaigns about bioaccumulation in the oceans. As you move farther into the exhibition, you'll come across the smallest work on display, The Birth of Snowflakes, by artist Anna Dimitru. Delicately suspended in the space are snowflakes made of copper. But they are not just decorative. These pieces introduce us to a fascinating scientific process, high-altitude bioprospecting, the collection of microorganisms such as bacteria or viruses from the stratosphere. To do this, scientists send sterile copper plates high into the stratosphere. When these plates return to Earth, any biological material on them is guaranteed to have come from the stratosphere, since copper begins as a sterile medium. So, why the snowflakes? Because real snowflakes form around a nucleus, and that nucleus can be something as small as bacterium. Each of Dimitri's copper snowflakes is unique, created using an algorithm that interprets the genetic code of a specific bacterium. To emphasize this connection, the artist has embedded natural RNA or DNA, rendered harmless, into some of the snowflakes. Next to the snowflakes, you'll notice raw copper in its natural form. This serves as a parallel between bioprospecting and geoprospecting, the mining of copper from the earth. The latter is often poorly regulated, with serious consequences both the environment and the workers' health. Dimitru invited us to reflect on these tensions between scientific advancement and extractive practices. Here we found ourselves in front of 2.5 vases. The third is broken, but don't worry, not by us. These objects draw inspiration from Celadon ceramics, once a key commodity along the ancient Silk Road. Artist Charlie Blackburn builds on this historical reference to explore a modern trade route, the flow of rare earth elements essential for today's technologies. Blackburn combines the traditional shape with modern materials twist. The glazes indeed are made with rare earth elements. This gives the vases their iridescent appearance, which changes depending on the light. Warm light brings out one color, cool light another. Take a moment, shine your phone flashlight or cast a shadow. Watch how the glazes shift color. This effect is made possible by the unique electronic properties of rare earth elements which belong to the lanthanide series of the periodic table. These elements are prized for their optical and magnetic characteristics. Though China dominates the market, over 90% of Chinese rare earth comes from Myanmar, where the environmental oversight is minimal. Though China dominates the market, over 90% of Chinese rare earth comes from Myanmar, where environmental oversight is minimal. Mining often leads to water contamination and radioactive waste, with severe health effect on nearby communities. So, despite the beauty of the vases, Blackburn message is urgent. We must rethink how we extract and use the resources that power modern life. This next piece, Cura Second, is the second version of an earlier work created by Alessio Manfredi in collaboration with the SAGacia curatorial team for the 2024 edition. It explores the impact of acid rain on marble, specifically how environmental pollution can degrade our artistic and cultural heritage. The installation simulates a polluted atmosphere in a sealed glass case. Inside, there is a liter of water acidified to pH 4, not with a mix of sulfuric and nitric acid as would occur normally, but with hydrochloric acid chosen for safety and control. The closed system generates a greenhouse effect, producing water vapor that condenses on the cooler glass. These acidic droplets fall onto the marble vase, slowly corroding it. Marble, made of calcium carbonate, is particularly vulnerable to acids. The white deposits you see are calcium salts, byproducts of the reaction that are more soluble than marble itself, meaning they wash away even more easily. Since this is a closed loop, the process needs to be restarted every few months by adding more acid. When the curator adds hydrochloric acid, it becomes a metaphor. We are the humans, continuously fueling the environmental arm. So, Manfredi's message isn't one of absolute condemnation, but rather a call for awareness. We can't eliminate all impact, but we can learn to pollute responsibly. This final piece, Fluctuation of Progress ND, is also by Alessio Manfredi. The title plays on words ND, stands for neodymium, a rare earth element used here in the ceramic glaze, but it also means not determined, alluding to the uncertain path of technological progress. To create the piece, Manfredi salvaged hard disk magnets and extracted iron and neodymium oxide, fusing them into a single glaze. Look closely and you'll see the colors: red for iron, violet for neodymium. The sculpture takes shape of an hyperbolic paraboloid, gently swaying before you, symbolizing how the progress moves and fits and starts, never following a straight line. The artist closes with a challenge. If I can do it, why can't industry? Today, recycling rare earth isn't always profitable, but that will change. As technology becomes obsolete, what we discard today will be tomorrow's raw material. Preparing now means embraces a more sustainable future. And that brings us to the end of SAGacia25. On behalf of the entire curatorial and organizing team, thank you for joining us. We hope this dialogue between art, science has sparkled reflection, emotion, and maybe even taught you something new. To explore the works and their themes in more detail, don't forget to access the digital catalog via the QR code. See you next time and enjoy the rest of your day!